Hello team. Let us now move on to the last class of regression wherein we talk about the model evaluation. Now calculating error, as you know, in regression is not possible calculating error in classification is not possible as we do in regression. Hence the column error, where we take the difference between the actual and predicted, is not possible here, because let's say we have the actual y versus the predicted y, wherein we have the four possible outcomes. That would be something like this. So these are the four possible outcomes. So what we can try to do is try to find out the accuracy in such cases. Now, so accuracy is nothing but what we do is we take the percentage of places where we are right. So let's say let us say that we have the actual versus the predicted. So it's something like we have 1 1 0 0 1 1, something like this, whereas the predicted would be something like this. Something like this. So there are few places where we are right, and there are few places where we are wrong, and so on. So easiest thing what we can do is to find out the percentage of places where we are right. Let's say we count all the number of places where we are right. Let's say we have about 8 places we are right, and out of, let's say we have 40. So what we do is we take the percentage of this. So this is nothing but accuracy. Now, finding. Now I have a question here. Let's say we are working on a model. Let's say we are working on a model where which predicts cancer. So we have the explanatory variables. We have the explanatory variables. We have the actual y, and we have the predicted y. In such case, so this is the model which predicts cancer. So we had explanatory variables. So what we do is we took X-ray for a few people and extracted few features here. Okay. Now we have developed a model to predict if a person has a cancer or not. Okay, based on these explanatory features. Okay. Now, if you can do an example is, what you can do is you can quickly go around your colony and inquire if a person is having a cancer or not. What you can observe is you will get hardly 1% of people having cancer. So let's do a thing. Let's call our model as stupid model. So that means this particular model, okay, gives out an output such that it has nobody has cancer. This is what my model tells me. That means nobody has cancer. So, but when I actually have an output with respect to actual and predicted, so what happens is that so my stupid model is giving an output as 0 for everything. For everything I have a 0, whereas in actual I have few places there are people who are having cancer. So effectively I am wrong in only few places and correct everywhere. I'm correct everywhere, whereas I'm wrong in few places. Okay, so I can say that still 99% my model is accurate. 99% my model is accurate. So this is a case where I get a high accuracy even with the bad models. This is the case where I get high accuracy with bad models. Although accuracy can detect during our preliminary understanding, when we have studied how a database is, but we will not be able to see things with accuracy itself. Hence, accuracy is not best possible measure when a problem of smaller class is very small. It is like when there is a imbalanced data set. When we have a data set where we have a smaller class and a bigger class of, where we have a imbalanced data set, accuracy can't work the best here. So hence we have to develop something else instead of accuracy to detect the correctness of the model. So in general, before that, in general, I can say that if a database with 20% or less smaller class, this database would be imbalanced dataset or database. All right, now let's see something which we can work on, building something which is other than accuracy. So that something is called as the confusion matrix. That something is called as the confusion matrix. So this confusion matrix looks something like this. It looks something like this. We have the actual here, predicted here with the negative and positive values. Okay, now what we have is, we have the actual value and the predicted value. This is actual target variable and predicted target variable. So we can have something like these outputs, and so on. So what you do is you summarize these into a confusion matrix. You summarize these into a confusion matrix. The simple things you remember here is, if a number is 0, in predicted, okay, it is negative. And if a number is 1 in predicted, it is positive. Okay, if a number is 0 in predicted, it is negative. If a number is 1 in predicted, it is positive. Whereas if a number is 0 in actual, it is called positive. And if a number is 0 in predicted, it is negative, whereas the number 1 in actual is called as positive. Hence, coming here, the first row is, it is 1, the actual is 1, whereas it has predicted 0. So it falls here. It is actually actually it is 1, actually it is positive, that is 1, whereas it is predicted as 0. So therefore that will fall here. So in such manner, if we randomly take all the values, let us say we have 7, 3, 5, 5. Okay, so this becomes a decent summary of our model. Now if I want to find accuracy from it, it is nothing but total correct divided by total. Now here the correct would be predicted as positive and it actually is also positive. So this is one total, and predicted as negative, actually it is also negative. This is the other total, that is 5 plus 7 divided by the total values, that is 5 plus 7 plus 5 plus 3. That would be about 12 by 20 or 60%. So therefore I can say that accuracy, the term is also derived from confusion matrix. So this is very important for a categorical variable, categorical data, to plot a confusion matrix for every model. Now let us move ahead and understand each variable in a confusion matrix. Let me draw a new confusion matrix. We have the predicted here, we have the actual here, that is negative, positive, negative, positive. Here we have the true negatives, that is the negatively predicted, and it is true, that is your negative, true negative. Here you have your false positive, that is positively predicted but it's false, whereas here you have the false negative, that is uh, negative prediction, it's a negative prediction but it is true. Okay, and the last one would be your true positive, that is this is those rows that are predicted positive and it is also a positive. Okay, this is very important to understand the true negative, false positive, the true positive and false negatives, where this is negatively predicted and it is positive. Okay, here it is positively predicted but it's negative, or in positively predicted it is false, whereas here it is negatively predicted but it's actually true. Okay, and here it is the row where the it is actually positive and it is also predicted as positive. Okay, So the output, if you plot a confusion matrix from an output from a logistic regression, you will get the confusion matrix in this manner. The output will look something like this. So in regression, the objective is the objective would be to minimize the error, whereas here in classification, our objective is not to minimize the error, but here objective is to decrease the error. That is decrease error. Here we had to minimize the error, whereas our objective is to decrease the error. Now, let us go back to our example of the cancer patient. Let's go back to our example of the cancer patient with the cancer patient. Here, our model was a stupid model where it gave a hypothesis that nobody has cancer. That is 0. Okay, now nobody had cancer. That means in terms of predicted positive, both will be 0. Okay, whereas here, since it is a biased database, so the actual and predicted on the negative side would be on higher. Let's say we have about 99%, and we have the actual database where people are having cancer. Let's say the database is having 1% of cancer, and it is predicted as they don't have cancer is 1%. Now this is the confusion matrix for people with cancer or a cancer database. Now here I have two major concerns. The concern will be here and here. That is my false positives, okay, and my false negatives. Okay. Now, with respect to these, this is nothing but my true positives and true negatives will be in line with the database and prediction, whereas these are the factors where I had to work on to decrease them. Okay, so now let's look at the other side. Let's look at the pros and cons here. Let's say let's work on the false positives. Okay, now false positives like people who were predicted that they had cancer. So if people are predicted that they had cancer but actually they don't have cancer, what they do is they just have to and they just have to undergo a confirmation test. You might do a CT scan or an X-ray or something like that, or MRI. Okay, now here is my false negative. It is predicted as a negative, whereas they actually have a cancer. This is a very dangerous one for our database now. That means here people have cancer, but our algorithm has not detected it. Now, this is loss of I wouldn't say opportunity, it is loss of information. So On here, it's a false positive. What you do is you end up wasting more money with the confirmation test and then getting a relief that it is not having, it is, you don't have cancer, and that is in a way it is okay. But on the false negative side, people who has cancer and it is not detected is on the dangerous side. They won't get the treatment they require and it is bad. It's a life versus death situation here. So considering the database, we should selectively decide which one needs to be minimized. Now, in a similar way, let me give you one more example. I would talk about the email spam. Now, for the email spam, everybody gets a spam and spam emails, and sometimes they come accidentally to our inbox, and most of the time Gmail automatically filters them to a separate spam folder. So here our objective would be to understand whether an email is spam or not spam. Now for this, let me come to the same table here. Now false positive, that is, emails are not actually spam, but they ended up as a spam. That means loss of information, business, or opportunity. That is false negative. That is, actually they are spam, but they're not credited as spam. So it is like they just come to your inbox and you have to manually delete them. Okay, it's just a waste of time. Now, with respect to earlier example where you had to improve the false negative, here you have to work on the false positive. So case by case, you have to selectively decide which one to be worked on, which factor to be selected from the confusion matrix. So I hope now you are very clear the need of confusion matrix. So in the both cancer as well as the email example, we try to understand what would be the number or mean in the business and minimize that. So collectively here, what you understand is we didn't just waste. We don't just want to build a model and check the accuracy, but we want to bring the model with respect to the correct situation. So whatever is that, whatever the objective is, it can be brought in here into a sprint categorical. This is why companies prefer to understand the business background and try to understand the business background, try to understand the case study, and then apply the data science part. So our keen sense of what is right and what is wrong should be first should be the first tuned yes, should be tuned first in order to then tune the data set. Now let's say I have option A where I have data set something like this: 10,000, 1,000, 4,000, 15,000. So this is about data set of 30,000 data, and option B, it could be something like 150, we have 10, 40 and 100. So in a whole we have data of 30. Now if you think carefully, which would be a better algorithm? So if you study it carefully, you might say that A is better. A is better, that is by checking at the ratios, and your gist is right here. Your gist is right because our objective is to minimize ratios, minimize the minimize the false negatives, minimize the false positives, minimize the ratio. That is our objective is. So ratio is what we are after and not the absolute factor itself. Now let us talk about this. Let's talk about these ratios. Let us talk about these ratios. Don't refer to this. These are just for my reference. Yeah. Talking to the ratios. Now I have the first terminology, that is recall score. I have the confusion matrix. Here we have the true, negative, and we have the false positive. We have the false negative and true positive. Now the meaning of recall is to remember. So what recall score gives is that is total positive predictions divided by actual positive predictions. Total positive predictions divided by actual positive prediction. That is, the positive prediction is the true positive. True positive divided by actual positive. Actual positive will be the sum of these two. So true positive plus false negative. So this is nothing but my recall score. That is, if 100 people are actually defaulted, how many are we are able to catch? This is recall. So recall is also called as sensitivity or also true positive rate. If 100 people actually defaulted, how many we are able to catch? Actually 100 were defaulted, how many did we able to catch? Okay, so in Python you do not worry about all this. All you got to do is you have to recall score of y actual versus y predicted. That's it, and you will get your score as the output. Nothing much to be done in Python, but understanding the theory, understanding the background behind it is something that you must know in order to just pull out this formula. Next one, I would say, it's the next important topic is the precision. So these two concepts will go hand in hand, and the second concept would be to understand precision. Now, precision, let me start with the confusion matrix. True negative, false positive, false negative, true positive. So this was recall, and that was recall, that is true positive divided by true positive plus false negative, whereas precision would be here. Precision, that is my true positive divided by number of positive predictions, that is true positive divided by true positive plus false positive. So precision talks about this, whereas recall talks about this. If algorithm says, 100 defaulters, how many will actually default? If algorithm says 100 defaulters, how many will actually default? Okay, this is the meaning of precision. So the difference is that in recall, that is, with respect to recall, if there was some number, okay, if there was a number, how many of real number we were able to catch? Okay, whereas with respect to precision, that is, if we have caught these many numbers, how many of them are actually real? So this is what measures precision in algorithm. Now, just like recall score, we also have the precision score, or the in Python is precision score followed by your y actual and y predicted. Okay. Now let me pull the formulas to you for your example. Let me now negative, positive, true negatives, true positives. This is false positive and false negative. Now for the recall, true positive divided by true positive plus false negative, and for the precision, it is true positive divided by true positive plus false positives. Now, in email case, in the email spam, case, okay, we tend to classify spam or not spam. Okay, and we try to classify spam or not spam, and we wanted to minimize the false positives. Okay, we wanted to minimize the false positives, the good emails which were going to the spam. So if we have to minimize this, that means we have to minimize this. That means we have to increase the precision of the model. We have to increase the precision of the model, and for that, for the email spam, precision would be the right tool or the right factor to judge our model. Okay. On the other hand, for the cancer data set, we have to minimize the false negatives. That is, the treatment gone missing, the detection of cancer gone missing. We have to minimize this. For this, if you have to minimize the false negatives, we have to increase the recall of the model. Recall of model, and that is where we need to understand precision and recall for better understanding of the business. So if you understand precision and recall in business terms like we understood now and apply it for each cases, then your problem solving will be much easier. Now coming to the last topic. Coming to the last topic, before that, let us talk about coming to the last topic, that is nothing but your false beta score. I think all this these slides, I think you can just study them once you open the LMS. You will have these slides ready and you can just go through them. But now what I'm going to do is I'll just wrap up the theoretical part just by explaining the F beta score. Sorry. Let us work on the F beta score. Before that, let us consider an example of a charity. That is predicted negative positive. Actual, you have the true negative and we have the true positives. This will be false positive and false negative. Okay, let's say you're donating laptops to students, to poor students. Okay, you're donating laptops to some deserving children. Now, what does this stands for here? The false positive. Actually, the student don't deserve it, but your model has predicted that the student would deserve the laptop. That is a waste of money. Okay, now if I have to reduce this, I have to work on precision. Okay, now for the false negative, it is nothing but actually the student deserves laptop, whereas it was missed in our algorithm. That is not achieving my social objective. So this is where I use my recall score to minimize it. Remember these arrows for recall and precision. So recall would be TP divided by TP plus FP, and for precision TP divided by TP plus false positives. FN here. Okay. Now let's say in the similar example, let's say we have too many laptops. I have too many laptops and I want to find a balance between these two, or in a whole I need to find a balance between my recall and precision. Okay, that is where what we do is we find the F beta score. We find the F beta score. F beta score is the method to combine both with precision as well as the recall. So the formula for F beta goes something like this: 1 plus beta square divided by F beta equal to beta square divided by recall plus 1 by precision. Okay. So there are few cases where you might find it confusing to which one to minimize, and therefore we will combine them together. We can combine those factors, precision and recall together, and you can work on F beta score. Okay. Now beta here is the ratio of your recall and precision. Beta here is ratio of recall and precision. Let's say you want to have you want to give a ratio or a weightage between the recall to precision. Like let's say I want to give 30% weightage to recall and 70% ratio to weightage to precision. So the beta will be 30 by 70, that is nothing but 3 by 7. Okay. Now beta score in favor of recall. Now beta square. Okay, this is the word beta. Now the beta square is rate in favor of recall. Okay, this beta square is the rate in favor of recall such that 1 is rate in favor of precision. Now if I want to calculate F1 score where beta equal to 1, so this formula will be 2 by F1 equal to 1 by R plus 1 by P, or F1 would be what you derive from this. So that would be mentioned somewhere here. 2 times precision plus recall divided by precision plus recall. 2 times precision into recall, divided by precision plus recall. That is what the formula you will get once you derive it. Now this formula is already available in sklearn, and just for your general knowledge, the beta square can range from 0 to infinity. So beta square can't be negative, but it starts with 0 and it can go up to infinity. Now this is where I stop the theory, and I'll be moving forward to the practical examples of showcasing the recall and precision, and as well as the confusion matrix in the next video.